Alright, now we're going to talk about rational expressions. A rational expression is a fractional expression where both the numerator and denominator are polynomials. So one example of a rational expression is 2x over x minus 1. Another one could be x over x squared plus 1. Really, it can be anything as long as it's in fraction form. So I could have 2x squared minus 16x plus 1 all over 3x minus 5. As long as it's a polynomial in the numerator and the denominator, it's considered a rational expression. Now that we know what rational expressions are, we're going to talk about how we're going to multiply two rational expressions. The first step is we want to factor everything. So we want to factor the numerators and the denominators completely. After we factor, we're just going to multiply the numerators together and the denominators. We're going to leave them in factored form though. By leaving them in factored form, now we can cancel any common factors that they might have. Alright, so let's look at our first example. So the first thing we want to do is we want to factor everything. So in this case, I'm going to start off with the numerator. So I'm saying what two numbers multiply to -3 and add to +2. So those two numbers are going to be +3 and a -1. So the numerator is going to be factored as x plus 3, x minus 1. Now we're going to take a look at the denominator. So what two numbers multiply to 16 and add to 8? Well, 4 and 4. So it's going to be x plus 4, x plus 4. Now we're going to move on, so it's being multiplied still. Now we're going to move on to the second rational expression. So what do these two terms on top have in common? They both have a 3. So I'm going to factor out a 3, and I'll be left with x plus 4. Now if we take a look at this denominator, we can't do anything to that, so that's going to stay x minus 1. Now I know in my steps I said multiply the numerators, but really you don't have to do that. In this case you can start cross-canceling. So if you want, notice I have an x minus 4 on the bottom and the top, so I could go ahead and cancel that out, as well as the x minus 1, so I'm going to cancel those two terms out. Now if I go ahead and multiply the numerators together, so what I have left, I'm going to get 3 times x plus 3, and then on the bottom I just have x plus 4. And this would be our final answer. Now there's no need to distribute the 3 in. We always want to leave our answer in factored form. Now that we've seen multiplying two rational expressions, now we're going to talk about how we're going to divide two rational expressions. The first thing we want to do is we want to change it to multiplication by taking the reciprocal of the second expression. Now after we take the reciprocal of the second expression, you're going to use the same rules as we did for multiplying. You're going to factor everything completely. After we factor everything completely, you're going to multiply, or again, you don't necessarily have to do this step, or you can go ahead and start canceling common factors. Alright, so let's go ahead and look at an example for dividing two rational expressions. So again, the first step is we're going to rewrite the problem, so a cubed minus 8 over a squared minus 4. Now we're going to change this to a multiplication. If we change it, we're going to flip these two. So a cubed plus 8 is going to go on top, and the a is going on the bottom. Now we're going back to factoring. So notice I have two terms. They're both perfect cubes, so you're going to factor them by using the difference of two cubes. So I'm going to take the cube, so I'll get a minus 2, square the first term, so I get a squared. Change the sign, so it'll be a plus. Multiply your two terms together to get 2a. And then when you square this last, when you square negative 2, you're going to get a positive 4. So that's my factored form. Now you're going to take a look at the denominator. Again, it's two terms, but in this case it's the difference of two squares. So it's going to be a plus 2 and then an a minus 2 times. Then we go over to the second expression. Notice again two terms, but this time it's the addition of two cubes. So again, take the cube to get a plus 2. Square the first term to get a squared. Change the sign. Multiply together. And then square the last. And then notice the denominator, you can't do anything with that. So I'm just going to get a. So now we're going to take a look. What do we have on the top and bottom that we can cancel out? Well, I have an a minus 2 on the top and bottom. And then I also have an a plus 2 that's on the top and bottom. So I can cancel those out. So I'm left with a squared plus 2a plus 4 times a squared minus 2a plus 4. And the only thing I'm left with in the denominator is a. So my final answer is a squared plus 2a plus 4 times a squared minus 2a plus 4 all over a.